Okay, so we've spent a lot of time doing basic LabVIEW programming. Now let's put it all together with the robot code. I think having done a lot of the upfront work that we just did in the hands-on, you're going to understand the code a lot better. So let's go and open up the code that we made earlier. Let's open up the code that we made earlier for the robot project. You remember? That was a project called Robot January 1st, 12:19 p.m., right? Remember when we made that code? So it's right here. I'm going to reopen it. And let's explore the robot main. One of the things that you should have internalized is that data flows through the project, and so when something's got all the data that it needs, it starts to run. So when we open up the robot main code, we can look for things that are going to happen when we hit the run button by looking for parts of the code that don't have an input wire to them. So as this opens up, we're going to look at the block diagram and look for items that don't have a wire going into them. Those will be the things that happen first, because if something's got a wire going into it, it's got to wait for the data that comes on that wire. So it can't happen first. Control E. So notice also that the front panel of the robot is very minimal. Robot main has no front panel. Why is that? Where's the user going to interface with the robot during the game? With what piece of software? The driver station, right? The driver station is your front panel. So we've basically got a faceless piece of code down in the robot that automatically updates the driver station as it runs. Control E. Here's the block diagram for our code. Ooh, there is a little change from last year, but I don't think it's all that important. Okay, what are the parts of this? What do we think that these things are that we're looking at? What does this look like, this gray thing? It's a structure that's a while loop. Okay, so this is a loop, and they call it the scheduling loop. I guess they expect you to know what scheduling means. But does it happen first? Does it have wires going into it? It does have wires going into it, so it doesn't happen first. So we follow these wires out. This thing, I don't know what that is, so I hit Control H. It says generate occurrence. Don't know what that means. That's fine. I've got another thing here which is a reference, which I don't know what that is, but it looks like it's going to something called test. And this thing here is a reference going to something called autonomous independent. Okay, that's good to know. And what is this one? Begin. Now that's something that I think I can understand. So I start here. What do you think this is? Is it a function? Is it a sub-VI? Is it a structure? It's a sub-VI, right? It's a square. It's got a picture on it. How do I open up the sub-VI? Right click. I open up the front panel. So already some of the things we've learned we're already using. Control E. So in begin, all of this stuff happens. Let me close some items down. I'm going to close this. What's the first thing that I probably want to do to work my way through this code? I want to bring up Control H, and I want to float over things. I see some items. I use my number one rule, which is I want to look for things that don't have a wire going into them. So these things don't have wires going into them. Ooh, what are these called? Oh, PWM1, PWM2. It sounds like they're talking about outputs for motors. That's good, right? That has a USB 1 on it. I wonder what that's defining. Oh, joystick, right? Okay, so that's good to know. There's some clues on this that there's a down arrow, so it looks like there's Ooh, look, it's choosable. Nice. So these feed into, I follow the wires, and I go to this. What is that? Sub-VI, function, structure. It's a sub-VI, so there's code inside of this, and it looks like this is a robot drive open. So this opens up your robot drive, whatever that means. And then over here, there's a more understandable one called, what's the word on the top of that sub-VI? Can you see it? Joystick. I know, sorry my bifocal friends. That says joystick. So we're basically saying there's a joystick out at USB 1. Does that make some sense? So what does begin do? Begin defines what's happening in the hardware. Great. If we work our way through the code now, begin, so I just closed begin, and now I'm back up at the main VI. And now what this thing here, it's a thick wire, so it's probably complicated. So we hit Control H. Ooh, and this has got information on it, 3 pieces. Status, code, and source. And those 3 pieces of data combine to make an error message. So if there is an error that's created by begin, it travels across this wire into the loop. So after begin starts, the loop, or after begin finishes, it'll send data on this wire, and as soon as all of the data gets to these 3 tunnels, so once this test stops running, and once auto-independent reference is gotten, after the reference to these 2 things are gotten, and after the reference to this occurrence is gotten, then this loop starts. So nothing starts until it gets all the data that it needs. And if there's an input to it, it believes it needs it. Right? So these 4 pieces of information come into this loop. As soon as it gets those information pieces, it starts to loop. Does that make sense? And what happens in the loop? Well, again, we can just follow the wires. So this happens. Wow, what is that? It says driver station get robot mode. What do you think the robot modes are? So there's probably one for teleop. There's probably one for autonomous. There's probably one for disabled. And so that comes over to this type of structure. What does this structure look like? Is it a loop? No, it's a case structure. It's got the question mark. It's got the case structure selector label, the case selector label up here. And I've got the arrows that can let me switch between the cases. And then the down arrow that lets me see the names of all the cases. What are the names? Autonomous enabled, teleop enabled, test disabled, test enabled, autonomous disabled, timeout, and finish. Well, there are some that we know what they mean, right? Let's go to teleop. Ooh, look. Teleop has one function in it, or one thing in it. What is it? A sub-VI called teleop. And we can right-click on this and go into it, Control E, and you see that there are functions. If I just read this, there are functions about the drive. This function here, for instance, is arcade drive. It has 2 inputs. What are the 2 inputs? Or it has actually 4 inputs. But 2 of them we understand, an X value and a Y value. Where do you think it gets the X and Y value from? X and Y of the joystick, and it turns out if we follow those wires backwards, we get axis 1 and axis 2 from the joystick. So you can now walk your way through this code by asking yourself questions, right? Where do these drive functions and these joystick functions come from? Right? Whoops, I'm going to actually do one small thing. I'm going to change what palettes are visible, because I sell NI stuff all the time. So I've got every palette known to man. And so that fills up the screen, and at this screen resolution I can't see what I want. So I'm going to delete everything but the first stuff. Okay, great. So now, notice when I right-click on the block diagram, there are some first specific function palettes. One of them is called the WPI library. WPI is Worcester Polytechnic Institute. They partnered with FIRST to make all the functions that will make your robot go. They have organized those functions into functions that are about the drive. Let's take a look in there. You can open motors. Whoops. Let me get all this on the screen. Whoops, let me do that because you gotta. Let me get back down there again. WPI, robot motor. So you got a 2-motor and a 4-motor drive open. So if you're going to use 4 motors, which of these 2 functions would you use in begin? The 4-motor one. It's not rocket science, right? There you go. There's another set of functions. Look at this. If you're going to run your robot in arcade mode, there's an arcade mode function. Here's one called tank drive, if you're going to use tank drive, guess what you have to do? Put this function in right into teleop rather than the arcade mode, right? Here's one for holonomic. Holonomic is the one where you can go in any direction. There's a function for that. There are functions for the joysticks. By the way, there are functions for sensors. There are functions for actuators. You want to put an extra motor on your robot to move an arm? That's the actuator part. That's where you're going to go. There are servo motors. There are motor controllers. If you want to know how these functions work for any specific thing, under Help, you can find examples about FRC. Under Help, you can go find examples for FRC functions. Now, they're not meant to work on your robot automatically. You're going to have to do some. You have to tell it what IP address to go to for this to work. You're going to still have to open the driver station for them to work and enable the robot. But what they will do is give you a good idea of how something works. You want to do pneumatics? There are pneumatics solutions. You want to do vision? There are vision functions. You want to do PID? There are PID functions. The first time you open the example finder, it has to build a list of all the examples, and it just did that. So if you are doing this in front of a group, you have to know what to say during that entire time. Okay, so there are FRC robotics functions. Let's say I want to learn how to use a joystick. Here's how I do joystick for tank drive. Great. So this example program opens up a project. Notice that the project is targeted to nowhere, so it's not going to work till I fix that. That'll be a topic for a different time. I can open up, however, the tank drive function. What the tank drive function shows me, A, is how to hook it up. See that? On the front panel, because this is a graphical programming environment, we can make graphics to show you how to hook it all up. How do you hook up? And how do you make the program work? You got to open a drive. You've got to have the tank drive function. What do you think's on this wire, by the way? Control H. If you open a reference to hardware, that is the information about that hardware. So this function basically says, I got two motors. They're going to be Jaguars. Notice there's a down arrow, so that's choosable. So if I had Talons, there they are. Now I've got this working for Talons. Now I've got it working for Victors. Now I got it working for Jags. Control E. On the front panel, where is my motor going to be hooked up in the real world? To PWM1. Where's my left motor? Where's my right motor going to be hooked up to? PWM2. What if I don't have it hooked up that way in the real world? Well, this ain't going to work this way. So if I'm in PWM3 and 4 over there for my drive, what do I have to do to this program? I have to switch it to 3 and 4. Right? Does that make sense? If I don't have my joysticks in at 1 and 2, I got to switch that. Control E. So I've got a joystick at USB 1. I've got a joystick at USB 2. I've got a function here that's called getAxis. Right? GetAxis is going to give you a value. So out of this, I get my Y axis. So this is looking for axis 2. By the way, each of your controllers has 6 axes on it. X, Y, trim. There's a trim pot. There's actually 2 trim pots on the bottom of those joysticks. And then I think you can twist them. You can twist it this way and twist it that way. That's axis 5 and 6. Right? So there are 6 axes. So it's not just X and Y, but again, if you're trying to be simple, X and Y is good enough for most teams. All right? So you're getting axis 2 out of these get joystick axis functions, which gives you the Y value for your left joystick and your right joystick, and you take your Y value for your left and right joystick and you stick it into the tank. So this example program just showed you how to program this up in the main program, in the robot main. Does that make some sense? So look for examples that do what you want it to do. Here's another big thing about the robot code. Let's come back from teleop. So we understand what's going on in teleop now. We're getting axis X and Y from joystick 1, and we're putting that into arcade mode. So like I said, you don't have to know anything about LabVIEW. That's already set up for you, right? If I close this, and go back into robot main, which is right here. Teleop mode is happening here. Begin is over here. So my example code had begin, had that hardware definition in the same space as the teleop command, right? Well, here I've got it in two different spots. Why is that? Well, it turns out that this robot has a lot of stuff going on. We just talked about the scheduling loop. Look at there, 4 other things happening in parallel with the scheduling loop. There's a function here called NT server. Never go in there. That's something that first figured out so that your driver station will talk to your robot. It's doing all the back channel communications so you don't have to. And it's got to be in there. What's this? Oh, sorry. I don't know what NT server is.
Variables.
It's variables. Oh, it's the variable engine that updates some of the dashboard stuff. Great. Here's the driver station code. This does the driver station communication. Never touch it. By the way, look at the outside icon of these sub-VIs. See, it has a loop, has a gray border around it with a little arrow. That means there are loops inside of each of these 5 things. So really, your robot is 5 loops all happening at the same time. You're talking to the driver station, you're talking to the dashboard, you're doing vision through the camera. Why would we put vision down here in its own separate loop? Remember what I told you about a loop and what times it? The slowest thing that's inside the loop times the loop. So this is back to your question from earlier, right? If vision, it turns out to get all of that information in from the camera, is slow. Takes about a quarter second. And if you want to have your joystick update your robot with new commands on where to go faster than every quarter second, which most of you do, you want that thing running as fast as possible. You don't want slow things up here in your scheduling loop. So vision is slow, and notice there's another thing here called timed tasks. And this is a topic for another time as you get good at this. But what timed tasks is for tasks that take a long time. Say you're going to hit a button and extend an arm and grab onto something so that you can levitate or hang, right? Well, if that task takes a long time to happen, you don't want it up in your teleop code. You want your teleop code to tell it to begin, and then it will begin on its own at its own speed down here, and you can still drive the robot so that you can then extend that arm and position the robot at the same time without one interfering with the other. So what we had to do is we had to split up begin from the activities that are happening in the robot from end. So let me show you a picture of that. And I think this is another one of the most important pictures from this presentation. So you've got 3 different groups of things, and they're disconnected from each other. Now, in that example code that I showed you, everything was connected by a wire, and that makes it real nice because it's really understandable. So when I come into this code, I open up Tank Drive, you see that everything is connected by a wire. Control E. This is wired up to that. No problem, right? So this Tank Drive is clearly driving whatever was defined by this 2-motor open. So this Tank Drive is going to run motors that are connected to the USB ports defined here. And this joystick is getting information from that joystick that was open there. The trouble is, when you've got 2 things connected by a wire, sometimes you can have execution problems. Let me give you an analogy. When you're driving in a car, if you are a passenger and you want to make a phone call, because you should not make a phone call while you're driving the car, right? And you want to make a phone call to another car where there's another passenger who needs to receive that call, can you do that with a landline? You could, but only if the cars are in sync with each other perfectly, right? And in your robot, you got 5 different loops that are happening at different speeds. So if you've got a car going at a different speed from another one, a landline's going to snap. So how would you place that call nowadays? With a cellular phone call, right? So what does that call do? That call goes from your handset in the car up to a cell phone tower, The cell phone tower knows your number, right? And it knows the number you're trying to reach, and then it connects to the other number. So your information goes to that cell phone tower and then gets bounced to the other phone where it's trying to be received. So what we have to do in the robot code is we have to, because things can be working at different speeds, we have to disconnect the wire every once in a while and make a reference, which is basically putting something on the cell phone tower, connecting it to the cell phone tower wirelessly. The way that we do that is described in this picture with these functions. Anytime you see a hashtag, it doesn't mean we're on Twitter. Okay? We made LabVIEW way before Twitter. Okay? So I call it the pound sign because I'm old, right? Whenever you see that pound sign, it means we're putting something onto the cell phone tower. So over here, in begin, we take all of this information about the hardware setup, we put it on one wire, and we put it into the cell phone tower, and we put it at a location. Now, with the cell phone analogy, like my number starts with 804. So you might say that I'm in an 804 location, right? But if you were trying to get in touch with me, you don't know that. So we don't want to use a number. You would rather say, I want to call Andy Watchline. That's why you put that in your phone book, right? You don't want to remember all those numbers. So we put information into the cell phone tower at a name. So we make a name in the cell phone tower that's called left and right motors. And we stick all of the information that we gathered here onto that wire, and we stick it in the cell phone tower for later use. So if you are now in teleop and you want to work the drive from teleop, which you do, we want to grab that information about where the motors are from that cell phone tower location. It's got to be the exact same name, and I mean exactly the same. Spaces, capitalization, the whole thing. So my suggestion is whenever you make this code, if you change this code and change the name, you copy and paste it directly from here to here. And you copy and paste it from here to there. So in time tasks or in autonomous mode, you might also want to run the motors. So you're going to have to put code into the autonomous code that gets information about the motors from the same spot. Okay? You might need to look at the joystick in your time tasks. So you're going to have to copy this code into that spot. So what's happening here is we're making a cell phone tower location. We're making a reference to the motors that we can use later on. Anytime we want to use those motors, we grab the information about the motors, which is on this wire, from the cell phone tower at this named location, and then we can use that information so that this drive will work correctly. Same thing's true here. So let's do a simple modification of the robot main. And I'll leave this as an exercise for you guys to do some other time because we're running out of time. I'm going to close all my examples, not save that. All right, so here we are. I want to go from arcade mode to tank drive. That means that I need to, how many joysticks do I need in arcade mode? One joystick. How many joysticks do I need in tank drive? Two. One for the left track and one for the right track. I've only got one here. So one thing I could do is right-click, go to WPI library, go to robot drive, go to joystick, and grab the open and the ref-num set. And I would wire them up exactly like they wired this up. I would right-click on the inputs and create constants for all of them. This is an enumerated text box constant. This is a string. I could build all of it from scratch. Or, if I was very clever, I could Control-C, Control-V. It's all hooked up for me. Now, can anybody else have my cell phone number? No. Can't happen, right? All cell phone numbers have to be unique. The same way, all names in the reference stack have to be unique. This is called joystick 1. I'm going to call it joystick 2. Or I could call it left and right. If I change this one, though, I got to change it everywhere else. So I'm just going to leave it the same, and I'm going to call this joystick 2. Can the joystick two be connected at the same location as the other one? No, so I gotta pick another joystick location, right? I do save. So I save this sub-VI now. Great. What else do I need to change? In teleop, I need to grab that new joystick, right? I grab my joystick. Actually, I'm going to make some more space. Remember that trick I told you, control, click, drag? I'm going to make some more space in this sub-VI. And I'm going to control, or I'm going to do, ooh, notice sometimes you have to move these things. So I'm going to move this away from the other one so I can copy it a little easier. Control C, Control V. Or another neat thing you can do is select these. If you have good dexterity, you can hit Control on your keyboard and click and drag. But you've got to be very sure-handed to do that. That's also copy. I like Control C, Control V because it's a little more controlled. Controlled, pardon the pun. Sorry, okay. What's the other thing I have? I can't use arcade drive function because I'm not in arcade drive anymore, so I got to take it out. I select it and I hit delete. I right click, I go down to WIP library, I go to robot drive, I use the tank drive function. I've already opened the motor reference. The motors are already there. They're at the same spot they would have been for arcade drive. I've already done that. I'm using two motors. I know that because it's all in begin. I've already called it left and right motors. So those are already set up. I just have to apply a different function to them. Click, drop. So now, which wire has the information about the robots that are, the drives that are already set up, the drive motors that are already set up? Well, Control H, I look at this. Notice there are only two outputs. From the cell phone tower, I'm going to get the information about the hardware I set up, and that information is on this wire. And this function needs to be aware of that, so I hook that information from this cell phone tower reading function over to the input on tank drive, which is appropriate. How can I tell that's the appropriate input? Because it says robot drive device reference. What did this one say, that output? Robot drive device reference. So I probably hook a drive reference to another drive reference. Great. What's on this wire, by the way? Control H. It's huge. Don't ever look at it. Don't ever look at what's on that wire. We had to make a very complicated thing to hold all of the information that might ever describe the hardware. And this is all of it. It's complicated. Don't go in there. Certainly don't change anything. So Control B removes broken wires. Now, which axis on the joystick do I use? X or Y to do tank drive? X is left and right, Y is north and south. I use the Ys. So here's my Y from joystick 1. That's the left one. So by the way, if I would have named these better beginning, I wouldn't have to know that joystick 1 was left. Ooh, and I didn't put a new number on this, so we got to do that. Whoops, Control Z is an undo. 2. Now I get the Y from 1 and the Y from 2, and I have successfully changed my code. Now, the other thing you should get out of this thing, other than the fact that you've got to put items into the cell phone tower and get items out of the cell phone tower for them to work between begin and other options. The other thing is anything you open, you should close and finish. If you don't close, you'll get errors. It won't actually make your code not work, but whenever something else is going wrong and we see all those errors piling up, it's hard to tell what's going on. Okay, so we come over to finish, and finish, as you can imagine, is in finish. I double click on that, or I right click and open it, and now what I have to do is copy this down here, and I put joystick 2, and I delete this erroneous copy, and now I've successfully modified my code to be tank drive. You can use this. Oh, just to be clear, how do I get this code down to the robot? I got to save it. I close this all up, and where do I go? I go back to the project. I go to build specifications, I build, and I run as a startup. Got it? Until you do that, it's not over on the robot for good. You can hit the run button right now, and it'll go over and communicate with the robot. It'll go down to the robot, but as soon as you depower the robot or close LabVIEW, it's not there anymore. Yes?
So you can run it without building it?
You can run it without building it.
Okay.
Takes a little bit longer, but if you don't want to go through the building, I would just get in the habit of every time you change a code, build it, run it as a startup. It's not that much longer. Okay? Just to be clear as well, the steps that I just went through are the same for modifying any part of the code. So if we come into robot main and we want to change autonomous mode, well, this is my place where autonomous mode happens. Notice, by the way, this just starts and stops the VI. That's here. I love you. Somebody just brought me Coke, which is great. Coca-Cola. Thank you. So you can double-click on this is actually a representation of the sub-VI. It's a reference to it, and I would, if we had more time, I would explain what a reference is, but we don't. I can double-click on this, and it opens up the autonomous code. So if I want to look at the joystick in autonomous mode, you would never do that. If I want to look at the drive motor in autonomous mode, I would come into autonomous. I would enable my code, or remove these disabled structures, which, by the way, that's what these comments tell you to do, is you can right-click on the edge of this and remove the disabled diagram structure. And notice what I've got now. I've got code that runs my left and right motors, and what's it doing? Well, it's sending constant values to my motors. So what's this doing? It's sending 0.25 and 0.5, so that means I'm sort of going forward and to the left in arcade mode. And over here, I'm going forward and to the right in arcade mode. And then I'm pausing for half a second, and then I'm standing still. You see that? So these are all drive functions. By the way, I'm going forward for, what does this thing do? Control H. Oh, that waits. And feeds the watchdog, by the way. So you want to use these waits, if you can, in the appropriate spots. If you wanted to add motor code to time tasks, you would have to go into here, get information, just like they've done here. They're getting information about the drives and getting information about the joysticks. What are they doing with it? Nothing right now. So you'd have to put your own functions in here that would drive extra motors or drive the drive. Okay? So you now know how to open references to hardware. You know how to execute a function, how to make a function happen, I should say. Executing a function sounds like you're going to shoot it, but you're not. You know how to make a function happen by hooking wires up to it. You know how to break, how to put information into the cell phone tower by going into a hashtag. You know how to get information off of the cell phone tower by getting information out of a hashtag. And all of those functions, you know where they live. They live down here under robot drives, under sensors, under actuators. So there's my set reference and get reference. There's my define the hardware through opening it, or open references to the hardware. And there's my actually use the hardware functions. All of the function sets work exactly the same way. They all have those things. You open, you put things into the cell phone tower or set the reference. You get the reference by getting information from the cell phone tower, and you act on that piece of hardware. They all work the same way. Okay? Let's see. Is there anything else that I want to cover in the last 3 minutes? Let's just take a look at some of the other slides. We've already talked about using the robot simulator. We've talked about adding a joystick. We didn't talk about adding actuators or camera. Where do you